Yo, 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 this is Mr. O. Yo, 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 this is Mr. O, and today we're going to learn about trapezoid. What is a trapezoid? Trapezoid is a under the quadrilateral, has four sides and has only one pair of parallel sides. Let's look at the family tree of a quadrilateral. Quadrilateral has four sides, and you have three options. Your options are two pairs of parallel sides, one pair of parallel side, or no pair or no parallel side at all. And trapezoid obviously falls on one pair of parallel side. And there's a special kind of trapezoid. It's called the isosceles trapezoid. Isosceles trapezoid means that they have congruent legs, which I'll explain in a while. But right now, we have learned already parallelogram, rectangle, rhombus, and square. All those four figures or polygons have opposite sides that are parallel. Okay, so let's go ahead now with trapezoid. So a non-isosceles trapezoid has only one pair of opposite sides that are parallel. On this case here, this side and this side here are parallel. And we know that this is a notation that they're parallel. While the segment that connects the two parallel sides are called the legs. These are the legs here. Legs. Okay, so that's a non-isosceles. Why is it isosceles? Because the legs are not equal. So contradicting, isosceles trapezoid have the same properties as the non-isosceles trapezoid plus these three things here. First, non-parallel sides are congruent. So this side here that are non-parallel has to be congruent. Diagonals are congruent. So this diagonal here must be equal. The base angle, where's the base angle here? The base angles are congruent. This angle, these two angles here are congruent. Likewise, with the two red angles here are congruent. And the opposite angles are supplementary. Means say, if you add this angle to that one or to that one, they have to be equal to 180. Okay, that's the difference between isosceles and non-isosceles trapezoid. So let's go ahead now here. So we know that this one here is a non-isosceles because the JM and the KL are not equal or it's not defined at all. So if this 87, that's 51 here, we know that the L and K has to be supplementary. Because according here, consecutive angles between the parallel lines are supplementary. Meaning say this angle here and that angle has to be equal to 180. This angle here and that angle has to be equal to 180. They have to be supplementary. So in other words, for me to find angle K, 180 minus 51 will give me, I think it's 129, but let me get my calculator. 180 minus 51 is 129. Very good. And then for me to know angle M, 180 minus 87 is 93. Kaboom. Okay, very good. Next, how do you find angle R here? We know again that this one here is not defined to be an isosceles. So we know that Q and R are supplementary. Okay, so therefore, 12x plus 3 plus 7x minus 13, that should be equal to 180. 12x plus 7x is 19x plus 3, negative 3 is minus 10 is equal to 180. Add 10 on both sides, that will give you 19x is equal to 190. So therefore, x equal to 10. Do we stop there? No, because we're looking for R. R is 7x minus 13. So 7 times 10 minus 13 will give us 70 minus 13, or I think it's 57, but let me double check. 70 minus 13 is 57. So the measurement of angle R is equal to 57. Kaboom. Just remember, guys, that if these two here are my parallel sides, the one that connects them, this and that one, has to be supplementary. Okay, it's not the Q and the P are supplementary. Okay, it has to be the one that connects the two parallel sides. So let's go back to isosceles trapezoid. So again, isosceles trapezoid, non-parallel sides or the legs has to be congruent. The diagonals are congruent. Base angles are congruent, and opposite angles are supplementary. So in this case here, it is defined that DEFG are is an isosceles trapezoid. So we know that DE is parallel to GF. Also, we know that DG is congruent to EF because they are the legs. This is your leg, this is your leg. Those are your legs. And what do we know about your diagonals? Diagonals has to be congruent. So we know that DF is congruent to EG. Okay. And likewise, we know that the base angles are congruent. So we know that angle DGF is congruent to angle EFG. Likewise, the other side, this portion here, which is angle GDE, is congruent to FED. They are congruent because those are the base angles. And we know that the measurement of angle DEF plus the measurement of angle EFG are going to be equal to 180. They have to be supplementary. This angle here, E, and angle EFG has to be equal to 180. Okay. Likewise with angle D and angle G there, they have to be equal to 180. So let's go ahead now and try this problem here. So we're given an isosceles trapezoid here, WXYZ, and we know this is 47. So I know that this has to be 47 also. And we know that if angle W is 47, angle Z has to be supplementary to 47. So 180 minus 47, that will give us 133. And this has to be also 133. By the way, how did I know that they're isosceles trapezoid? Because you see this thick line here? That tells me that the legs are congruent. So therefore, angle W is 47, angle Y is 133, and likewise, angle Z is 133 degrees. All right, so we're given here M and OP is an isosceles trapezoid, so the legs there are congruent. MP is 16x minus 13, so this is 16x minus 13. NO is 9x plus 8. So I know it's an isosceles, so the legs has to be congruent. So I know that 16x minus 13 is equal to 9x plus 8. And I can solve the x there. I'll do it in a while. So PN is the diagonal, which is 5y plus 19. And likewise, the other diagonal is 12y minus 37. And I know they're equal. So 5y plus 19 is equal to 12y minus 37. Solving for the value of x here, minus 9x there, that will give us what? 7x. And 13 there will be 21. So therefore, x equal to 3. And move the 5y to the left, that will give me 7y. Add 37 here, that will give me 656. And divide by 7, so therefore y is equal to 8. So the values of x are 3 and 8.